Hi, this is Bililign Amare. In this video, we'll see bisection methods for roots of equation with Python programming. The first step is choose the lower and the upper point. That means L and U. In this case, if you substitute L and then U, and then if you multiply them, they have to give a negative numbers. So if that satisfies, there will be at least one real root between the 2 pointers. Let's see it with example. Here is y is equals to x cubed plus 2.625x squared minus 3.875x minus 19. So we are trying to find out a real root for this function. If you just plot the graph, you will have such types of layout. So if you see from this graph, there will be a real root between 2 and 3. So let's just select the lower part is as 0.2, and then the upper point is 3. And then if you substitute 2 in the function, that means f of 2 will be minus 8.25. It is a negative number. If you substitute 3 in this function, so it will be 20. And then if you multiply them, the number will be negative number. So there will be at least one real root between the 2 pointers. The second step is just estimate the root in the middle point. That means we'll sum the lower and the upper, and then we'll divide it by 2. So it might be the root. And then once we get that, the third step will have 3 conditions. So we'll substitute that root in the function. So if you just multiply the lower end with the roots of that function, so f of L times f of R, and then if they becomes negative number, so we'll update the upper interval to be the root. So u will be the root r. And then the other condition is if you just multiply the 2, and then if the number is positive, we will update the lower one. So L will be r. And then if you multiply the 2 and then becomes 0, then that means we got the roots of the equation as exact value. So at that time, we will terminate the program. Now let's write this programming in Python. I used the Jupyter Notebook to write this programming. So let's just write the title with a comment that's bisection methods. And then the second step is we can just use the lower and the upper parts here. So L is the lower part. So let me comment on that. So it is lower interval. And then u is just the upper interval. So I'm just writing the 2 parts. Once I do this, let me show you how we could state the function that might be useful to substitute any number in that part. So we'll use a lambda keyword in Python. This lambda function is very useful to evaluate any number in that function. For example, f of x is equals to x squared plus 5. If I have this types of function, so how we could substitute different numbers in this function. So the first step is we have to write this one as f. So f is equals to lambda. So lambda, I can use this lambda function of x. So the variable is x in this case. So I will just pass a colon. That means after this, I will write the given function. So the function in this case is x squared. So double asterisk 2, then plus 5. So if I substitute any number by calling f, then that means it is just a usual function as f of x. For example, if I want to print f of 10, that means if I substitute 10 in that function, I will get 105. So if I substitute the value as 2, so if I just call as f of 2, so the value will be 9. That means 2 square is 4. 4 plus 5 will be 9. So this lambda function is very useful to evaluate different functions as f of x, or as usually we call it as y. So once that's the case, now we have the lower part and the upper part. So let me write that function. So in this case, f is equals to lambda, the variable in this case is x, so colon, then I will write the function. So x double asterisk 3 plus 2.625 times x double asterisk 2, that means a square, so minus 3.875 times x minus 19. Now let us write an if statement to identify whether the root exists in two intervals. So if f of L then times f of u less than 0, then let's just print real root. Now if you run this programming, then yeah, it says real root. So there will be at least one real root. If this condition is satisfied, then we can further find out that root. Now let's estimate the root as r is equals to L plus u over 2. The third step is to identify whether f of L times f of r is greater than 0, less than 0, or exactly 0. So if f of L times f of r less than 0, then colon, then we'll update the upper interval. That means u will be as r. That means upper value is now becoming equals to the roots of r. To see if this is true, so let's just print upper is modified. If this statement is not true, so we can use the other elif statement, that means else if. So elif f of L times f of r is greater than 0, the lower part L is equals to r. Then to see if this is true, so let's write just the lower is updated or modified. The lower is modified. And then in the third condition, if the two conditions are not true, that means if f of L and f of r exactly 0, so if f of L times f of r equals, that means exactly equals, that means equal is 0, then just print this is a root, so root, and then comma, let's just print that part. Now let's run this. Then if you just run, you'll get upper is modified. So the first condition is satisfied in this case. However, to have a good result, we have to repeat again and again this step. So to repeat this, we can use a for loop or a while loop. For example, if I want to repeat this for 10 times, then I can simply use a for loop. So in this case, let me write here. So for I in range 10, then colon. Now we can indent all the three conditions to be part of this for loop. So simply I will select all of them and then press the tab key, so all these parts will be part of the for loop. Or simply you can rewrite if you are interested to write all of these lines. So all those conditions and then including the r value will be as a set of this for loop. Once we do this, let me check the programming. So if you just run this part, so in the first part, upper is modified, lower is modified. In the third iteration, the exact root is already found here. So the root is 2.375. After that, if you just look the remaining iteration, it becomes 2.375 because the third condition is satisfied. To check that, let me print one condition here. So print f of r. So in this case, if you just print f of r, it should be 0. So as expected, if you just print that, it is just 0 because for the roots of equation, our interest is to get a value that makes the equation 0. Here, normally if the third condition is satisfied, we don't need to do any further iteration. So at this time, we have to break the loop. So we'll pass just simply I'll pass break. So if it gets the root, then it will break from that loop. So if you just rerun this, you will get this part. Now let's finalize our programming. So all those conditions might be executed once if we have f of L times f of u is less than 0. Else, we can write this, else, if this condition is not satisfied, then let's pass as print no real root. No real root. So the program might be run in this way. So all of these conditions or all of this programming parts should be in the parts of the first statement. So I just paste all of those things in this part. So if f of L times f of u less than 0, then print there is a real root. So once that condition is satisfied, then this for loop is opened and then it will execute until it gets the root or the maximum iterations of 10. If the root is not found on this 10 iteration, so simply we can print the approximation value. So we can pass the root is equals to then comma is r. So root is equals to, this is a string, so it will be displayed, and then once it passes that, then finally it will give this value. So the final value will be 2.375. And the other thing, normally we don't need this message, so we can delete the print parts of this one. Upper is modified, lower is modified. Let me just delete this lines, then let me pass this one. For example, let us modify the equation. Instead of minus 90, let's make it as minus 20. If you just pad that, and then if you just run the program, you will get the real root as a root is equals to 2.41308, and then it will continue in this way. And then if you just print f of that function, you will get negative 0.014. That means the real root is not exactly this number, but it is just approximating to 0. So to improve the accuracy, we can add the number of iterations. So instead of 10 iteration, let me use range 20. If you just pass that, you'll get almost 2.4136119 as a root, and then if you just evaluate f of that number, it is minus 1.977 times 10 there is minus 5. So it is just approximating to 0. Normally we can use round keyword to shorten these numbers with a significant digit. So let me pass that one. So round, and then in bracket r comma, let me pass 5 or 4 significant digits. So you'll get 4 significant digits after point. And then the same thing for f of r, we can pass round f of r comma 4 significance of digits. So if you just pad that, it will give you as 0. Keep coding and then see you in the next video.